I call this problems involving momentum and energy. Hey, there's a collision and there's a change in height, change in speed, curvy path. Let's smash stuff together and have it move off afterwards. We're going to start off with a review question. So it says this: a 30-gram bullet moving at 380 meters per second strikes a 5-kilogram wood block at rest. You know, probably I would underline the word at rest, because that's one of those, hopefully by now you've clued in, that's one that's always worth taking note of. Makes the question easier and sticks into it. Oh, they stick together. Elastic or inelastic? I just heard the last syllable each time, so I'm not sure which one you said. No. Inelastic. Elastic, rubber band, bounce. Inelastic, the opposite of that. Okay. If the block and bullet move together after the collision on a frictionless surface, A, write a momentum equation, and B, find the speed of the block after the impact. Sheldon, is there a collision? Yes. This is a job for conservation of momentum. If you really wanted to argue with me, you could say the momentum equation was the sum of all the momentum before equals the sum of all the momentum after. And I would accept that as your momentum equation technically, although we're going to break it down a little further. I'm going to call this B for bullet. Oh, B for block. Oh, how about W for wood block? So I'll have mass B and mass W. Is that okay? For the collision, Sheldon, what's moving? The bullet, the wood, both, or neither? Okay. Do you remember what momentum is? Momentum is what times what? Okay, I'm going to take a little shortcut, and I'm going to then say it's mass of the bullet, velocity of the bullet, and initial. Is that okay? Wham! They collide. Did I get you, Trevor? I got you mid-yawn. Did I? Oh, I saw the mouth open there. I don't know. Oh, come on. You missed that, didn't you? After the collision, Sheldon, what's moving? The bullet, the wood, both, or neither? After the collision, what's moving? The bullet, the block, both, or neither? Both. Did you see how you could reason your way there with a little bit of wakey, eggs and bakey? Yes? Yeah. Stuck together or separate? Together. How could you tell that it's together? Oh, yeah. Okay. So I'm going to go like this. Mass of both V final. And, you know, I'll put the vector signs to remind myself to be careful with direction, although I don't see anything bouncing backwards or anything like that. But just to remind ourselves, momentum, we did have to be a little paranoid. That's really the answer to question A. If you wanted, I would say that's a better momentum equation because that's got the stuff broken down. What does B want me to find? The speed of the block and the impact. Oh. I guess that's V final? How would I get V final by itself? Divide by M both. Okay, so V final. Have I gone over the momentum test with you guys in class yet? I don't think I have I? I'll do that next class. V final is going to be mass of the bullet, V bullet initial, all over mass of the bullet plus mass of the wood. I'll break both up into what it really is. Is that okay? All right. So this is hopefully, Alicia, a review of what we did about a month ago. I've scrolled down. What was the mass of the bullet? 30 grams. 30 what? You said grams? Yeah. Okay, I can't do that. 0.03 kilograms. 0.03. You notice I'm sticking as much unit conversion in as I can along the way. Initial velocity of the bullet?
380 meters per second.
I could have given it to you in different units and had you do the conversion. Okay. And 0.03 plus, what's the mass of the wood block?
5 kilograms.
Okay. You get 2.27? 2.3? I'll go 2.27 meters per second. Okay. John, we brushed the cobwebs off, I hope? Yes? So here's the thought question I want to ask you. Before we had computers, before we had slow motion, high speed video, how did the FBI, how did the RCMP, how did police departments do ballistics? How did they figure out how fast bullets could travel? It's not like you can time it with a stopwatch because human reaction time is way too slow. They didn't have radar, anything like that. How could you figure out how fast a bullet was traveling? And the answer is use a little bit of conservation of energy and a little bit of conservation of momentum. You invent something that we call the ballistic pendulum. Like example 2. Like example 2. You hang a mass from a string. We call a mass hanging from a string, Haley, a pendulum. That's where the word pendulum comes from. You fire a bullet into that pendulum. Ballistic pendulum. Got a latecomer. So ballistic pendulum, bullet, pendulum. So what we're going to do is we're going to have it hit, and you know what? I think it sticks together. Okay? I stole this picture because it was a nice black and white picture. They're using tiny lowercase m for the bullet and uppercase M for the big, huge mass. Can we do that okay? It's a little weird having M and M, but we can do that. Okay. So it says this. A bullet of mass 0.005 kilograms, very lightweight bullet, is traveling at 330 meters per second, speed of sound. It strikes a wooden pendulum bob of mass big M equals 0.85 kilograms and sticks. How high will the bullet and the bob swing? Prith, my friend, is there a collision? That's a job for conservation of momentum. Is there a change in height? Is there a change in speed? Is there a yucky, curvy path? That's going to be a job for conservation of energy. And the key to doing the ballistic pendulum is you break your question into 2 parts. And I really mean 2 parts. I'm going to draw a line right down the middle of the page. And on the left side, I'm going to label this the collision. And on the right side, I'll label this the swing into the air after the collision. So just to help you visualize, we're imagining you have the pendulum hanging. When the bullet hits it, whack! The 2 of them stick together and go swinging up into the air. How high? How high? Did I say collision? This is a job for conservation of momentum. The sum of all the momentum before the collision equals the sum of all the momentum after the collision. Better be important, Haley. Or you could put the phone away. Or you were typing really fast on your calculator, and if you were doing math on your calculator that fast, I apologize. Because that I would have been proud of you. Okay. You know what, Sheldon? I'm going to argue actually the collision is exactly the same as the question that you and I just did. So I'm going to write here, see previous example. Sheldon, I've scrolled down. Can you read to me the V final equation that we ended up with?
V final equals mass of bullet.
So that's going to be little m,
Yeah, and we'll also use the bullet.
VI all over little m plus big M.
Yeah.
Yeah? You okay with us taking the shortcut there? Okay. Oh, I see someone who's not okay. I'm sorry. Wham! They collide. There. Now you're okay with it, Rebecca. Sorry. I forgot to throw that in there. My bad. That was terrible of me. Okay, we got that in. Bullet is 0.005, 330 all over 0.005 plus 85. How fast do they start to swing at? I don't know. 0.005 times 330 divided by bracket 0.005 plus 0.85, right? Did I say 85? 0.85. That's an 85 kilogram mass. That'd be terrible. 0.85. Do you all get almost exactly, but not quite, 1.93? All right, 1.93. I'm going to use this, so I'll keep this answer stored on my calculator. 1.93 meters per second. You okay with that? The swing. The swingy part. Matt, in the swingy part, is there a change in height? Is there a change in speed? Is there a yucky, curvy path? You know what that's a job for? Conservation of energy. G. Okay. KE initial plus PE initial. That's right at it, right after impact, the split second they start to move, equals KE final plus PE final. If you want to, on your diagram, you can label this right here as final, and this is going to be initial for the swing part. Are any of these zero? PEI? Because we all know Prince Edward Island is not really a province, right? I mean, come on. Let's be clear here. You're not a premier, you're a mayor, right? Let's be honest. Okay. Uh-oh, that's on YouTube. I'm going to get hate mail from PEI. They have mail there? Oh, sorry, that flipped out. Okay. Anything else? Zero. You agree with that, okay, Haley? At the top, for a split second, you do come to a stop. Final KE is zero. And one of the nice things, because energy is a scalar, we're going to decide that's the ground. Why not? Oh, this is going to work out kind of nice. We're going to get a half mv initial squared equals mgh final. Now that little m is actually the mass of both. Oh, wait a minute, Alex. Is there an m in everything on the left-hand side? Is there an m in everything on the right-hand side? So even though technically it is the mass of both, it's the 0.85 plus 0.005. Turns out, meh. That's kind of nice. Matt, what did this question want me to find? Oh, can you get h by itself, please? Okay, so if I hear you correctly, you're telling me the final height is going to be VI squared, which VI after the collision, the 1.92, that thing, divided by, instead of a 1/2, I'll just tuck a 2 down there, yes? And G. Okay. I have this number still here, squared, divided by 2 times 9.8. 0.19 meters, 19 centimeters. Is that okay? Yeah. Ryan, I don't know if you remember, but I opened this by saying, how could you, before we had radar and computers and slow-mo, how could you calculate how fast a bullet was traveling? Let's suppose you did this experiment, but what you measured was the height. If you knew the height, if you knew this height, could you calculate this V? Could you get that V by itself? Say yes. If you knew this V, which is this V, could you calculate that V? Say yes. And now you can figure out how fast a bullet is going. This is ballistics. Nowadays, we do it much more modernly with fancy schmancy equipment and radar and all that stuff, but there you go. Wasn't that tough to do? You reverse this. In fact, I think the next one we do reverse this. Let me see. Sure. All of you get to be 1930s and 1940s RCMP officers or FBI agents. A 5-gram bullet is fired into a ballistic pendulum. If the bob has a bob is what you call the mass hanging from a pendulum, has a mass of 2 kilograms, and it rises a vertical distance of 8 centimeters, how fast was the bullet moving? Oh, and then you would compare that to a chart of different bullet speeds, and you would say, I know what gun it was. I know what kind of gun it was. They do that nowadays, Cohen, but with fancy schmancy equipment. Okay? Gonna make it, Alex? Because that's a mighty long staring down at the floor there at nothing. Yeah. You'll find you learn better if you tilt your head to vertical. I know it's a vector and 45 degrees. No, vertical works better. Just saying. This question's going to have 2 parts. It's going to have a collision part and a swing part. John, we're going to reverse this whole procedure. John, we're going to start with the swing, because it wants to figure out VI, how fast the bullet was coming in. By the way, this question here, great Physics 12 question. In fact, on one of my tests in Physics 12, I do include this. I'm not going to assess you a combined momentum energy question this year. I might next year in Physics 11, but I've redone everything this year. But good preview of coming attractions. So let's target, John, the swing. In the swing, now I didn't do a picture. Can we imagine same picture? Is there a change in height? Is there a change in speed? Is there yucky curvy? Okay, so the swing, we're going to start out by going right, John? Were any of these 0? Yeah, of course, PEI is nothing. I mean, they got a bridge, good for them, but otherwise, come on. What are they really? Potatoes? Okay. I'm going to get myself in trouble here on YouTube. Anything else 0? Yep. Okay. What we're going to do, though, what we want to figure out is how fast the bullet and the block started moving. We want to find on this side VI. It's going to be a half m v initial squared equals mgh final. John, the masses cancel. For what it's worth, it is the mass of the bullet and the block together, but they cancel. Yay! I want to get the VI by itself, John. How would I do that? Where is this 2 on the left-hand side on the times by 2? Okay, don't make that mistake on a test or a quiz, because it's an easy one to do, because you guys suck at fractions as a group, and it's not your fault. The curriculum doesn't emphasize fractions the way it should. So you're telling me I can do that and that? Cross out the 1/2. By the way, you can also just divide by a half, but dividing by a half is the same as timesing by 2, and Ryan, timesing by 2 is much less intimidating looking. Yes? That's v squared. So let's write this one more time. VI is going to be the square root of 2 times 9.8 times 0.08. Now we'll see. I was doing all this in my head, making up the numbers. Andy, I might have a really, really slow bullet. I don't know. I'm hoping it's okay. Or I might have a crazy fast bullet going like half the speed of light or something. I don't know. We'll see. Do you get 1.252190 at that? I'm going to write 1.25, but I'm going to keep this on my calculator. Now let's go over to the collision. Wham! They collide. Before the collision, momentum, yes, John? We're taking a little shortcuts here because I want to get you lots of time to work on your homework. Before the collision, what was moving mass? A bullet, pendulum, both or neither. So I'm going to have this. Mass of the bullet, V bullet initial. After the collision, what was moving? Mass 1, mass 2, both or neither? Stuck together or separate, Sheldon?
Together.
Thank you. Sorry, I had to come back and just make sure he was, wakey, wakey, eggs and bacon. So it's going to be mass of the bullet plus mass of the pendulum, V final. Now, here's the key, John. V final, after the collision, is V initial during the swing. And we want to find V bullet. See it sitting there in the equation? How would I get V bullet by itself? Yes. Nice. So it's going to be the mass of the bullet and the mass of the pendulum, V final, divided by mass of the bullet. This is how it was done back in the day. So the incoming velocity of the bullet is going to be 5 grams is 0.005 plus. I scrolled over it. Where is it? 2 kilograms. V final, 1.25 divided by 0.005. Bracket. John, I can add 0.005 plus 2 in my head. It's going to be 2.005 times the 1.25 answer button divided by 0.005. Please give me a good speed. Oh, but 1.5 times the speed of sound. This is a rifle. 500, is that right? 502 meters per second? No, yes, no? I'm not seeing any other nodding. Nobody tried it? Hedrick's nodding? Matt's nodding, but that probably just means he doesn't like it, saying no. You really threw me off with that one, man. That was like, wow, body language. Okay, don't know. So, velocity of the bullet initial, what did we say? 502 meters per second. This gives you also, for those of you that are taking Physics 12 next year, a bit of an idea of, I would consider this in Physics 12 a C or a C plus question. In Physics 12, most of your questions are going to be multi-step and even multi-step, okay? But by then, you've got the vocabulary, you've got the background. Then we also throw in angles and it gets even tougher. But the fact that this has no angles, we would consider this next year a fairer walk in the park. So that's the ballistic pendulum. Hey, let's smash some roller coasters together. Example 4. A 3 kilogram car traveling at 18.5 meters per second east collides. Underline the word collides. What is that a trigger for? What does that tell me we're going to use? Okay, now this time Alex has gone all the way over to this side, so he's 45 degrees to his right. That's good. I mean, on average, your head is straight up. So I like that, but let's keep it going, kiddo. You guys got to sleep. You got a long weekend tomorrow. Sleep tomorrow. Hey, collision, that's a job for? Conservation of momentum. That's my trigger word. I know I'm doing momentum. Oh, I also see in the picture a change in height and a curvy path. What's that a job for? Energy. Conservation of energy. Is that okay, Linz? Okay, get your hand off your head to head. Boy, this is a sorry looking group. Lindsay, what does part A want me to find? Height. Here's what I think is going to happen. This one's at rest. This one's moving along. Wham! They collide. When they collide, I think the speed will change. I'll have to figure that out. Then, all of that kinetic energy will get turned into potential energy. In other words, this is also the ballistic pendulum in disguise, in that I'm going to divide the question in two. I'm going to have a collision. I'm going to have, well, not a swing this time. I'm going to have a hill. Okay? Linz, let's tackle the collision. It is a collision, so it is a job for momentum. Before the collision, what's moving? Car A, car B, both or neither? And momentum is what times what? Okay, so because you gave me that, we're going to take a shortcut. I'm not going to write the sum of all the momentum before equals the sum. And I'm not going to write P plus P equals P. I'm going to go straight to, what did you say momentum was equal to? So before the collision, mass of car A, velocity of car A. I got a great joke for you, Trevor. Knock, knock. Wham! They collide! Okay. You guys are dead this morning, so I got to bring a little thunder here. Lindsay, after the collision, what's moving? Car A, car B, both or neither? Stuck together or hang on. Sheldon, stuck together or separate? Oh, very good. What's the fancy word for stuck together? Inelastic. So it's going to be mass A plus mass B, V final. Mass of both, V final. Linz, I want to find out how fast they travel after the collision. I want to find V final. How might I do that? You don't say. Cool. V final is going to be the mass of car A, velocity of car A, divided by mass of A plus mass of B. What was the mass of A? 3 times 18 divided by, Lindsay, in your head, could you please add car A and car B's masses together in your head, please? Thank you. Three times 18.5 divided by 5 equals, oh, that's nice, 11.1, even works out okay. Then, Jess, my joy, they go up a hill. Jess, is there a change in height? Is there a change in speed? Is there a curvy path? Conservation of energy. So over here, let's go KE initial plus PE initial equals KE final plus PE final. Jess, are any of these 0? I have no idea what you said. Prince Edward Island? Are you slamming Prince Edward? Really? You know, they're a province just like anybody else. How dare you? Yeah, we know that. Anything else 0? Did you say KE final? By the way, do you see mathematically, that's why I said this is identical to the ballistic pendulum. Mathematically, in terms of the physics, it is. And we're going to get a half mass of both, V initial squared, equals mass of both, GH. Now, even though I wrote mass of both, Jess, you want me to go like that because there's a mass in everything, yes? Jess, what's part A asking me to find? How? I heard divide. Divide, thank you. So H is going to be VI squared divided by a 2. Timesing by 1/2 is the same as dividing by 2. And a G. It's going to be 11.1 squared divided by 2 times 9.8. 6.29? 6.3? Is that okay? Yeah, yeah? Here's a little thought experiment. Suppose we make the hill steeper, or decrease it, less steep. So the hill is not as steep. With this decreased slope, the cars will reach lesser height, same height, greater height. You know what? This is a chance for us to vote. Once again, how high you hold your hand up is how sure you are the answer. So, the hill is not as steep. Who says, oh, they're not going to go as high because the hill's not as steep? Lesser height. No one. Who says same height? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Who says even higher because it's not as steep? 1, 2, 3. Is that a 4 over here? Some of you didn't vote. Convince me. You can answer this. Yeah.
The equation only cares about height, so.
In fact, it's going to be this, and you can answer it with one word. You can say, it only cares about the height, not how you got there. It's one of the reasons why conservation of energy is so flexible. It really lets me look at some really ugly situations, roller coasters being, Trevor, the classic example, and say, I don't care about how many dipsy-doos there were between the top and the bottom. I just care about where the top and the bottom were. Oh, if you take Physics 12, conservation of energy will also then allow us to include loops in roller coasters, because we don't care about the top shape. Just care about how high you are. Yeah, I'm putting that on YouTube too. It says work on the unit review. Actually, you're going to work on lesson 6 and the quiz. I did promise you time. This lesson is Physics 12. This idea, a lot of Physics 12 is, hey, here's a question where you're combining 4 or 5 different topics. You can really, you get that neat aha moment when you realize how it all fits together. I really like that part of it. There will not be a combined energy and momentum question on your test. But this was also, I think, a nice review of momentum, though. I have a video to show you.